Welcome to lesson number 33, Learn C Programming on the Raspberry Pi. Okay, today we're going to do a little bit of work on the Raspberry Pi, trying to calibrate a USB temperature probe. So let's get to it. First we'll go over to the Pi. And this is lesson 33, so let's make a directory. Let's see, lessons, mkdir lesson -33. Directory lesson-33. Okay, so we'll start Genie. And we'll wait for that to come up. In the meantime, I want to show you the temperature probe I'm using. So I'll bring up Firefox here. And we'll go over to this company called Vernier. They make a temperature probe here. It's a USB temperature probe, so you can actually do this experiment on any computer, not necessarily the Raspberry Pi, because you just need a USB port. But this is the probe I'm using, called the GoTemp probe, and you can see in my video here on the screen I have the GoTemp probe. It's plugged into my USB port on the Raspberry Pi, and I also have a beaker here of ice water where I can try to calibrate it and see what the readings I get at 0 degrees Celsius. Okay, well, the first thing we need is, let me clear out some of these older files. First thing we need is a new program here. And I'm also going to include UNI-std.h, which I'm going to need for the sleep function. And let me save this guy to get some color into it. So I will save it as, let's see, I want to go into lesson 33, and I'll just call it get temperature.c. Okay, well, I looked up the stats or the spec sheet for the probe here. Let's see, I have it. This is that GoTemp probe. So I looked up the specs on it, and basically it gives out 8 bytes of information on a regular basis, and those 8 bytes can be interpreted somehow as temperatures. So let me first introduce you to the type-def statement, which I don't think we've used yet. What I'm defining here is a short form for an unsigned character, and I just call it U8. Type DEF unsigned short U16. So U8 is basically 8 bits long, where I can store an integer number, basically 0 to 255. And unsigned short, the U16 short form that I've defined here is a 2-byte unsigned integer. So I think it can go up to like 65,000 or something like that, 65K more or less. Anyway, so now I'm going to define the structure I need that I'm receiving from the probe. I'll just call it structure. I'll call it data. Okay, so this is what I read on the probe's website to give me some information on what those 8 bytes look like. So U8 MP, and I'll try to explain these in a minute here. U8, so there's the first byte and the second byte, and then I have M0, a temperature here, 16, oops, another temperature, and 16, another temperature. And so there I've defined my data structure basically for what I receive from the probe. And let me bring up Firefox here just to show you where I get that information from. There's a tutorial here. I believe somewhere near the end shows you the structure. Right here. So you can see basically the data coming from the device. It gives you 1 byte here, which is the number of measurements in the packet. Gives you another byte, which is just a rolling counter, and then it gives you 3 measurements that are 2 bytes each. Measurement 0, measurement 1, measurement 2. So I can just add in here, well, you know, there's no point. All I'm really interested in is these measurements here, which give me an indication of what the temperature is. Okay. So I'm just going to ignore these other guys up here. I won't bother with them. I don't really need them. But I will read them in, because altogether, you see, I have 2 bytes here, 2 bytes here. That's 4. Another 2 bytes is 6. Another one here is 7, and then the last one is 8. So there's 8 bytes. The size of this structure I have is 8 bytes. Okay. So now I can go into main, and I can say struct data, and I'll just call it T. That's my structure. And now I also need a file, because I want to read from the USB port. So file, I'll have a file pointer. Let's see, FP, my file pointer. And I guess I also need my temperature, supposedly. So I'll just take float float. I'll just call this my Celsius temperature. Or CEL. Can't remember how to spell Celsius. SC. Well, I'll just say degrees C. Okay. That saves me having to look that up. Okay, so now what I'll do is I want to start a for loop, because I want to loop through about every 5 seconds getting the temperature. So for int I equals 0, I is less than, let's say, 300 tries, I plus plus, and maybe just before that, what I should do is just open up that file. So I'll say fp is equal to, so you know what, I think I'll just put it right on the initialization line here. fp is equal to fopen, and I want to open up, and it's slash dev hid raw0. That's the USB file that I have to open on the Raspberry Pi to read the USB temperature probe. And I want to tell it that I want to read in binary. I want to read in binary data. I can just open that. Now what I should do is I should check, for example, that I have opened it. Like, for example, I could put in here if fp comes back to be 0, null, then I haven't opened it. But if the pointer is something like an address, then I have opened it. So I'll just say if not fp, then I can just say, for example, printf can't open port /n quote. I'll just do something like that, then I'll say ex exit, I don't know, 22 or something. So I'll just exit the program if I can't open up the USB device. Now you have to have root permission, by the way, to open that. Okay, so continuing on in our for loop here, I want to read that structure. So I'll say fread, and I want to read into the address of t. So I'm going to put the data I read, I want to put it into this variable t. I'll make this a little bit bigger here. Okay, now how many bytes am I going to read? Well, I'm going to read, if you look at this structure is 8 bytes long. So I could just say I want to read 8 bytes. I want to read 8 bytes. And how many items am I going to read? I'm going to read 1 item. Basically 1 item that's 8 bytes long. And where am I going to read it from? I want to read it from fp, from this file. Okay? So once again, I'm reading from this file. I'm reading 1 item, which is basically this data structure called T, which is right here. I give it the address of the data structure right here. I'm reading 1 item, and the length of that item is 8. Now normally we don't hard code the 8 like that. What we usually do is we do something like this. We use the size of operator, and we say that. So this size of struct data will return an 8, saying that's how big the structure is. Okay, so we read this guy in. Now that we read it in, we can actually print some of the stuff out. Or, I guess we can, let's see, let's do it like this. Printf I'm just interested in this guy here, for example, M0. When the thing stabilizes, my understanding is that these three guys are all the same. Okay, but for now, let's just print out one of them. I'll just print out M0 is %d/n. So we'll just print out M0 like this, and comma, and it's really T dot M0 because it's the M0 element of T that I want to print out. I just want to print out this first guy here. I'm reading in all 8 bytes, but I'm just going to print out M0 of the structure T. Okay? And then what I can do is I can then sleep for 5 seconds, and that'll be the end of my for loop. And then when I finish the for loop, I can just say, I can just close the file up, FP, like that. And then I can say return 0 and that. And that's the end of my program. But let's see, sleeping for 5 seconds 300 times, that's going to be a lot. Let's just do it 5 seconds for 5 times. Let's just do it 5 times. 5 seconds times 5 times is 20, so the whole loop will take 25 seconds. Okay? Okay, so let's save this guy. What I can do is I can compile it here. I can use build and just say build, and let's see if it compiles. Oops. Warning. Oh, C is unused. It just gives me a warning message saying well, I got another error up here. Let's see. Oh, I don't have exit. I don't have exit declared. So let's go here. We'll say man exit. And I should include std live. Did I do that? I did not. So let me include that std live for exit up here. Okay, so I include that. And then I'm not using C yet, so let me just comment that out. I'm not using that yet to calculate the temperature. I'll save it and I'll just try to compile again. And I still get something wrong here. Oh, I guess I need a do I need round brackets around that? No, I shouldn't. Let's see, what do I have wrong here? Compilation failed. Line 3. Oh, no. Line 21. No effect. No effect. It's a warning statement of some kind. I think the main problem I have here is, let me just say, let me just go and compile it here without the warnings. Because when I do the build here, it gives me all these warning. If I look at the set build commands, you can see here it gives me all my warnings. Warnings all. So it's giving me all kinds of warnings that I don't really want to look at right now. So what I'll do is I'll just compile it without the warnings right here. say GC or C99 get temp minus O get temp. Okay, and oh, I still get boom. Expected semicolon before numeric constant. Let's see what that exit looks like. Oh yes, I need the brackets around it. Silly me. I need to have the brackets there. Okay, so let's put the brackets there. I'm supposed to be teaching you, and I'm making too many mistakes. Okay, so let's try building it here with the warnings and see if we get that. Oh, okay. So now it compiled successfully, and I should have executable code, and I can execute it now, / get temp. And you see I can't open USB port because I am not super user. I'm not the root. So I'll go sudo / get temp. And now you can see the reading is 1904. And another one is 2688. 2688. So it looks like it's the steady reading is 2688. Okay, so this 2688 represents basically the room temperature. Okay, in fact, you can see if I put this probe into ice water here, just put it in there a little bit, and then you'll see the thing will start going down. See the numbers, that M0 starts going down to different values. Okay, so, and it's going to continue falling down until it stabilizes. So see, it's not really stabilized, so we don't really know yet. But anyway, I'll take this guy out, and I've already done all the calibration myself. Basically, if I just take this, if I put this C back in here, let me see if this works. And what I do is, after I finish reading 5 of these guys, just after I close it, what I'll do, well, actually, just a minute, let me just put it right in here. After I get the temperature here, I'll just say printf. You know, I don't even need the C there anyway. I can just do it like this. Say temperature is, let's say, what do I want to do it here? Let's say percent 5.1 F /n quote comma, and I'll just take M0 and I'll divide it by, I think, 127.0, which is the number I came up with. So I don't really need this intermediate guy here. I'll just do it like that. So if I just take that number M0 that I get and I divide it by 127, that should give me roughly a temperature in degrees centigrade or Celsius. So let's give it a try. I'll save it, and then I'll do a build on it. And whoops. What's wrong now? Oh, can't be M0. It should be, sorry, it should be T dot M0. Okay, just like I have here. Remember, M0 is a component of T, so it should be T dot M0. Another mistake. Save this guy, do another build, and this time it works. And now I'll run it again. Get temp, and you can see, well, the first one is not really accurate. The 11, remember I took it out of the ice water, so it's about 11 degrees Celsius. It's about 11 degrees Celsius right now. Okay, and what I can do is I can just take it, I'll change that loop here to let it go for a long time. For example, I'll let it go to 100. 100 times 5 seconds is 500 seconds, so that's a long time. And I'll do the build again. And then I'll execute it here. And now you can see it's up to 12. See, it's warming up. In fact, if I take my hand and I hold it here, if I hold that probe here, it's still cold in my hand. I can feel it's cold, but you should see it start to rise. The temperature should start going up, hopefully. I have no idea why it's not going up. Yeah, there it is now, 13. Actually, it should go up quicker than that. Okay, let's try something else. I'll break this guy. Let me do it like this. What I'll do is I'll do an open. I'll say here FP equals open. I'll put an open and close right inside the loop. So I'll take this guy out here like this, and so I won't bother with this because I know I can't open it. And then what I'll do is after I get the temperature, I'll close it. I'll close it inside the loop like this. So now what I'll do is I'll open it up. I'll do a read. I'll print out M0. I'll compute the temperature. Then I'll close it. I'll sleep for 5 seconds and I'll go back and do the same thing. So I'll be opening and closing all the time. Let me see if this thing compiles here. Build. Okay, and I'll go and try it again now. Hopefully it's more than 13 degrees by now. Oh, it's up to 22.4 degrees. Let me get my hand again on it. Let's see if I can get it up there. 23 degrees. 23.7. So now it's going up 24 degrees. Okay, so you can see it's kind of working now. And if I take the probe and I put it into the ice water, stir it up a bit, hopefully you can see it start to go down to getting down to 0 degrees, I think 0.9 degrees. So it is getting down to 0 degrees Celsius. Okay, then I'll take the probe out. Again, try to warm it up. Oh, it's really cold now. I'll try to warm it up with my hand. And you can see the temperature should start rising, 13 degrees, and so on. Okay, so basically that's our experiment for today. Just wanted you to have an idea of how to use structures in a real live situation, and also learning the typedef command. So that just saves me, instead of, for example, here I could have just typed unsigned character. Here I could have typed in unsigned short, but it just makes it more convenient to do it this way. Okay. Okay, so let's update our notes a little bit here. So our file IO, we learned a new, I guess we learned, I don't know where I'm going to put this typedef here. Arrays, structures, language, C language statements. I think I'll just put it up here. typedef, typedef, just to define some new type. Save that. Go back. Okay. Okay, so that's it for today's lesson, and I'll see you later for lesson 34.